On this type of expedition, we're doing many different things, but for me, the coring side of things is the most exciting. We have an idea about what's down there and what we should be getting back in any core, but when they come up on the deck and they're unpacked from the core barrel, you never quite know. Here, by accessing the fault, we are hoping to be able to evaluate what does it take to move one part of the Earth's crust past another part of the Earth's crust. And what I mean by that is like how much you have to push it, what's the stress acting on the rock and acting on the fault, and how much does it take to be able to get the earthquake to move this enormous distance.
So we're here right on top of the fault that slipped by many tens of meters during the Tohoku earthquake and displaced the seafloor and generated the giant tsunami that devastated the coast of Japan. And we are doing this in 2 locations. One location is on the rock and the sediments that overlie the Pacific plate before they kind of enter the damage zone or the collision zone where the 2 plates meet, so that we know what they look like before anything happens. And then our second site is going to be across that fault zone, across that damage zone where the 2 plates meet, so that we can kind of see the before and after.
Once a core arrives on the ship, a certain number of things happen to it just to kind of like prepare it for analysis. And then we have a team of people who then kind of like take turns to do lots of different kinds of measurements on it. Other people at the same time are looking and trying to understand what the materials are made of, how they're arranged with respect to each other, have they been mixed up by all the tectonic activity here in some way. And then there's other people who are trying to understand, like, okay, these complicated rocks, where have they come from? What are they made of? Like, do we understand them here where they are today compared to their lifetime where they were formed previously? So these cores have come up from some hundreds of meters below seafloor. They've been assessed for various physical properties, and we've looked at them and tried to figure out what they're made of and where there are variations in them. Scientists are now taking samples so that they can take little pieces of this and take them back to their labs back home and do different kinds of analyses that we can't do on board the ship. So this is for their personal research after the expedition.
We're still in our coring operations now, but so far we've been able to achieve all of our targets, including a full transect through the prism from the seafloor all the way down to the décollement. We recovered the décollement. We did it, which was very exciting to see that come on deck. And in fact, we were able to make 2 passes through it. And then we were also able to recover the complete stratigraphic section on the incoming plate, all the sediments on the Pacific plate. And right now we're gearing up towards trying to go for the basalt, so the incoming plate, and at 2 sites. So we're on track.
The drilling has been really amazing, and the core recovery has been fantastic, and it's a really big advance on 12 years ago. And I think this is the first time, to my knowledge, that a fault anywhere has been re-investigated after a gap in time of 10 years or more, and this sort of equivalent set of measurements have been made. But, you know, come back again and we can add to the time series and really fill out that picture a lot more.